For lesson 5, we're going to look at reflections over non-axis lines. So first off, we are going to be looking at reflecting over lines in the form of x equals. X equals some number will be here. So this first example, we are reflecting over the line x equals -2. So first step is we're just going to graph that line, x equals -2. So let's think about it. X is -2 right here, and it's not on this axis, it's on every single point on this line, because every single point on this vertical line has a value of x equals -2, which sometimes confuses people because they think, well, the y-axis runs vertical. You're right, but this is where the x value is, -2. So I'm going to highlight this here. And then I'm going to count the distance from the point x equals and plot that, okay? So looking at point A, we've got 1, 2, 3, and then I'm going over 1, 2, 3. So right here is A prime. That is at the point 1, 2. For B, 1, 2, 3, 4, 5, 6. So I'm going over 1, 2, 3, 4, 5, 6. That's B prime. That's at the point -8 and -3. And then for C, we're going over 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. C prime is at the point 4, 7. So what we'll notice there is what value stays the same. Right here, the 2, the -3, and 7 stayed 2, -3, and 7. So the value that stayed the same was the y value. Our x's changed. Now we're going to look at reflecting over lines in the form of y equals. So here we're looking at the line y equals 3. So we are going to start by graphing that line. Where is y 3? Well, the y value is 3 right here, which means every single point on this line has a y value of 3. And I'm going to highlight that. And now we're reflecting up and down on the opposite way. So if A is 1 below, A prime is going to be 1 above. And that's at the point -5, 4. B is 1, 2, 3, 4, 5, 6 below, 1, 2, 3, 4, 5, 6 above. And that's at the point 4, 9. And then C is 1, 2, 3, 4 above, 1, 2, 3, 4 below for C prime, and that's at the point -8, 1. Sorry, -8, -1. Now looking at my values, what value stays the same? In this case, the x values stayed the same. Now we're going to look at reflecting over the line y equals x. So first thing that we're going to do is I'm going to plot that line so we can visualize where it is reflecting. So where does y equal x? Well, our intercept is at 0, 0, and it's just going up 1 over 1, up 1 over 1, up 1 over 1. So it's this perfect diagonal line going through each point here. I'm going to use a ruler to make sure that's straight. And this is the line that we're looking at reflecting over. Because it's a diagonal line, we can't just like directly count up and over like we were on the past. So instead we're going to use this rule that our ordered pair that was x, y, flips around to y, x. So I'm going to write the reflected pairs first. So my y value is going to become x, and my x value is going to become y. And I plot that point. That's at 2, negative 5. 1, 2, 3, 4, 5. So that's A prime. And if you look at that, that kind of looks like it reflected over the line. So for B, that 4 for X is going to move to Y. That negative 3 for Y is going to move to X. And then plotting that point, negative 3, positive 4. And again, that kind of looks like it reflected over the line. And then for C, that negative 8 for X is going to become Y, and that 7 for Y is going to become X. And plotting that point at 7, negative 8. And there we have it. Last part, reflecting over the line Y equals negative X. Same thing like for the last one, we're just going to plot the line negative X. So our positive slope went from the bottom left to the top right. It's going to be the opposite now, starting on the top left, going down to the bottom right. So we still have the intercept of 0, 0, but now we're going the opposite direction. Up 1, left 1, up 1, left 1, and so on. Same thing here, over 1, down 1, over 1, down 1, all the way through. I'm going to use a ruler to draw a straight line through here. I'm going to highlight that so we can visualize what it's going through. And then we're going to apply the rule. So it's almost the same. Up here, the Y and the X just flipped. Down here, the Y and the X are going to flip, but they're also going to become the opposite sign. So this negative 5 is going to move to the Y, but it's going to become positive. This positive 2 is going to move to the X, but it's going to become negative. So plotting that point, negative 2, positive 5, 1, 2, 3, 4, 5. There it is reflected across. For B, this 4 is going to move to the Y, but it's going to become negative. This negative 3 moves to the X, but it becomes positive. So plotting that, positive 3, negative 4. 1, 2, 3, 4. Barely reflected over there. And then the last one, that negative 8 is going to become Y, but it's going to become the positive value. And this positive 7 is going to become X, but it's going to become the negative value. And then plotting that, negative 7, positive 8. It's right there. And then these last examples, we're just going to apply those rules, not using a graph. So here we are reflecting over Y equals X. And remember that rule is that they flip positions. So our X becomes our Y becomes our X. Next example, our X becomes our Y becomes our X. And then this last example here, we're flipping over the line Y equals negative X. The rule for that is they flip-flop, but they also flip-flop signs. So this X is going to move to Y and it's going to become negative. This Y moves to X and becomes negative. This X moves to Y and becomes positive. This Y moves to X and becomes positive. And that's it.